By special request, let's go back to the Azure ML Designer, but this time it's personal. Welcome to this video on Azure Machine Learning. My name is Kevin Fiesel, and I'm the proprietor of Galaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. Early on in this Azure ML series, I showed you how to use the Azure ML Designer to create a drag-and-drop pipeline to train a model. After that, we set up a real-time inference pipeline, consuming our model via web service. But today, I'm going to satisfy a viewer request. The people demand a video on how to perform batch inference from a designer pipeline, and today, I'm going to give it to them. Now, without further ado, let's go to the demo and see how it all works. Here we are, as usual, in the Azure Machine Learning Studio. If you followed along in this series, you're already pretty familiar with the Designer tab in the Authoring section, but let's jump in there for a moment anyhow. Inside here, I have a training pipeline called Chicago Demo Video at the top of my Pipeline Drafts listing. But I'm going to navigate over to the Pipeline Jobs tab, as that's where the real action is. Up at the top of this list, I have Chicago Demo Video, which I ran recently. Let's select that link, as it will take us to a completed version of our training pipeline, and I won't need to wait for training to complete before showing off inference. As a quick reminder of this model, we are reading a data set of Chicago parking tickets and using a two-class decision forest to decide whether or not a person is likely to pay their City of Chicago parking ticket. This graph is simple, but it does what we need it to do. In a prior video, we created a real-time inference pipeline, but in this video, let's do something different. I'm going to select the Create Inference Pipeline menu and then choose Batch Inference Pipeline from the drop-down menu list. This will take a few moments for Azure ML to generate a new graph for us, but eventually it will do so. By the way, one thing I should point out is that this auto-generation only happens if you build your entire training pipeline from Designer components. If you train a code-first model, you won't be able to create a batch pipeline quite that easily. But now we have the frame of our batch inference pipeline. I want to point out a few things here, starting with the top left. The TD Chicago Demo Video node is a depiction of the transformation options that we need to perform against raw data. We didn't do much transformation of our input data set, just replacing missing values of tract and police district with the mean values and removing any rows that had zero features. So there's not much going on there, but we still need to have this. At the top right, we have our input data location. By default, this is the Chicago parking tickets dataset that we trained against. But that's only going to let us predict against files in that dataset, and I think that defeats the purpose of a batch inference system. So let's select that component and make sure the Properties flyout pane is open on the right-hand side. Then I'll navigate to the bottom of the Parameters tab and choose Set as Pipeline Input. We can give this any name we want, so for the sake of having something a little different, I'll call it CPT Data. These two nodes meet in an Apply Transformation block, and there's not much for us to do here. Then, the output of this transformed dataset gets fed into a Score Model component. We also need to send in a trained model, and that's what the MD component is on the left-hand side. It's our trained model. At the bottom, we have an Evaluate Model component. This only makes sense if we already have a label and know our answers. But because I'm going to send in data where we don't have labels, it doesn't help us, it doesn't give us any value. So I'm going to delete this node altogether for batch inference. And that's our batch endpoint. Let's first select Save from the menu so I don't lose anything. Then I'm going to need some data. I have a file that contains every column except for Payment is Outstanding. Let's navigate to the Data tab in the Assets menu, and then I'll choose Create to add the new file. I'll call this Chicago Parking Tickets Batch Inference, and choose tabular from the V1 dataset types. For this kind of batch inference, we can only use a tabular dataset, not a folder. Next, let's select the Next button and choose the data source. I'm going to upload the file, so let's choose From Local Files. On the page after that, I'm fine uploading it to Workplace Blob Store, so let's continue on. Now I have an option to upload files or folders. I'll upload the file called Chicago Parking Tickets Batch Inference. That'll take a few moments to complete, as the file is almost 50 megabytes in size. It contains roughly 463,000 entries, so we definitely want to perform this as a batch operation instead of trying to predict this many items via web service. You can do that with the web service, but I would recommend doing micro batches of maybe 100 or 500 entries, and so you'd have to build all of that infrastructure and run it against our web service. With this, I just upload the one file, and once the upload is finished, I can select the Next button and move on to the next page. It was smart enough to realize that this is a comma-delimited file in UTF-8 format, and there are headers. Everything seems reasonable here, so I'll continue to the next page after that, which is the schema page. Scrolling through this list, I don't see anything too untoward, so I can move on to the final review step by selecting Next one more time. When I'm happy with the settings, I can create and build out an Azure ML data asset. Now let's get back to the job. That was a little sideshow distraction, but necessary for us to perform inference. I can get to it from the Designer tab. At the top of my pipeline drafts list is the Chicago Demo Video Batch Inference Pipeline, so let's return to it. Then we can choose Configure and Submit from the top right corner. From here, I need to choose an experiment. I already have a perfectly reasonable experiment in Chicago Demo Video, so let's keep using that. There are a few other options on the screen to make things more helpful for a group. You can set the job display name, create a description for the job, add key value pairs as tags. I'm not going to need any of this, so let's just select Next. Now I need to choose a data asset. We've just created a new data asset, so let's use it. From the menu, I'll select Chicago Parking Tickets Batch Inference and choose the latest version. I don't have any outputs, though if I wanted to write results to a separate blob storage location or something, I could set that up here. After selecting Next again, I get to choose my compute. I already have a CPU-based compute cluster that will work fine for the job, so I'll move right along from there and review the settings. It all looks fine, so let's choose Submit and see what happens. Pretty quickly on, I get an alert that there is a new job brewing, so let's click on that link and move away from the Designer and into the Jobs tab. Now, this may take a little while for compute to spin up, for components to validate, for the process to finish. And I think we need to fast forward to the good stuff. Okay, that took a bit of time, but now it's done. Let's see what we've got. If I select the Score Model component, I can right-click on the component and choose Preview Data and then Scored Dataset. This brings up a quick visualization of my outputs with histograms of each feature. Scrolling all the way to the right, I can see two new columns, Scored Labels and Scored Probabilities. It looks like the large majority of our predictions are that people will pay their tickets, with well over 90% expected payment rate. If I choose the Scored Probabilities column, we can see that the majority of data comes in with probabilities of non-payment somewhere between 0 and 30%, and the highest probability of non-payment for a single record, if I mouse over the tiny little sliver, it's somewhere around 80%. If I want to get to that data, let's right-click on the Score Model component again, and then I'll choose Access Data and the Scored Dataset. This brings us to Azure Blob Storage, where I can see the output file in Parquet format as data.dataset.parquet. I could grab that file and import it into any system that supports Parquet, allowing me to work with that output data outside of Azure Machine Learning. So there you have it. We've created a batch inference pipeline using nothing more than the Azure ML Designer, and we used that inference pipeline to generate predictions for over 460,000 data points. Not bad for a day's work. And that was batch inference pipelines in the Azure ML Designer. Like I mentioned at the top of the video, this topic was a commenter request, so if there's something you want me to delve into further, leave a comment and there's a reasonable chance I'll make it happen. We'll have links and show notes in the description below, and until we see each other in the next video, take care.